In this video I'm going to be explaining how computers can store negative numbers in binary. We're going to look at two specific methods, even though only one is actually used, but there might be questions on it in the exam. So this is normal binary here down the bottom. You can see that I've got 1 byte and it's all represented with 1, 2, 4, 8, 16, 32 and 64 and 128. So there's no way to do a negative number here. You know, this is the binary for 64 because I've got one of the 64. But what could I do to store negative numbers? So one way you could do it is, instead of having this as representing 128, it could say whether the number was positive or negative. So a 0 would be positive 64, so that's positive 64 here. And to do negative 64, you just put a 1 in. So this would be negative 64. So you've got the 1 and the 0. Now that sounds like a really good idea. I mean, why? That's really obvious. You lose a column, so we're going to have less numbers. So obviously here, this number, you can go from 0 to 255. Okay, that's how much you can get. The lowest number is 0, is 0, 0, 0, 0. And all ones, if you add up all these, is 255. So without negative numbers, you can have 0 to 255. There we go. But with the sign bit, and this method's called the sign bit method, or okay, because this is a sign, 0 meaning a positive number, and a 1 meaning a negative number. There is a couple of problems. First of all, one of the problems is you get two negative numbers. So for example, you get a positive 0 and a negative 0. So 1, 0, 0, 0, 0 is the negative 0, and 1, 0, 0, 0 here is positive 0. I'm going to get rid of this. And this doesn't happen in normal maths. You haven't got a positive or negative 0, so that's really weird. Okay, because you don't want... Now you've got two numbers that essentially represent the same number. You've got 1 and all zeros, and 0, sorry, that should be 0. 0 and all zeros here. So both those, that's normal 0, that's negative 0. So that's terrible. So a sign bit, one issue is you get two zeros, positive slash negatives. That is one of the problems with a sign bit method. The other problem is simply that the mathematics doesn't work. So in our binary adding video, you should find out how to do binary adding, and you should know how to do it. So let's add some numbers together. Let's do 7 and minus 3. Okay. So 7 is simply 1, 1, 1, and minus 3 would be a 1 at the start here. Okay, so this is 7. And this is minus 3. Because you can see it's a minus because we've got 1 here. Now let's add them together as we've done the video. So you should know that 1 plus 1 is 2. So I'm going to use this row as my carry row because I don't have the ability to do small little ones here. So 1 plus 1 is 2, so that would be 1, 0 in binary. So we put the 0 there and the 1 in the carry. Let me just sort that out. Okay, so 1 plus 1. I'm just going to highlight a different colour as well so you know it's adding up. So 1 plus 1 is 2, so that's 2, 1, 0. Then we've got 1 plus 1 plus 1, that's 3, so that's 1, 1. Okay, brilliant. Everything's looking okay so far. 1 plus 1 is 2, so that's 0, 1. And then 0 plus 0 plus 1 is 1. And then from then on, we get a few zeros. 0 plus 0, 0. And then 0 plus 1 is 1. Okay. So that seems, at first glance, okay. But then let's look at the answer. You've got a negative number. Okay, it's correct, because it should be minus 4. And then for some reason, we've got negative 10. Because that's the 10 negative. What it actually has done is added them together, but just kept the negative. This doesn't work. Also, if we add two negative numbers together, 1 and 1, we get a number over the top here. And as you should remember from before, that's called an overflow, or a carryover. And that completely doesn't work. So, these are the problems, really, with the sign bit. You get two zeros, and the math doesn't work. I mean, they're the major problems, really, it doesn't work. So that's not how we do it. But they're the two things you might need to write in the exam. You get 2 zeros, the math doesn't work. It also, because it has 2 zeros, you lose a number. So the range of this is minus 127 to 127, because obviously all these numbers add up to 127, 1, 1, 1, 1, 1. And so you've got minus 127 here, and 127 there. So minus, sorry, that would be ones. So that's minus 127, and that's 127. But that's actually 255 combinations, whereas actually when we do 0 to 255 on normal 8 bits we have 256 combinations. So we're losing a number there because we have 2 zeros. So how do they do it? 2's complement. Well, 2's complement works like this. It's actually a lot simpler to understand in our head. Instead of the first one being a sign bit, it just represents negative 128. So let's do the same number we did before. Let's do minus 7. Now that's actually quite hard to do now for us, but it's easier for a computer, because basically, I'll put in some numbers here. Let's put 1, 1, 1. So that's, I'll put 0 there. So this is minus 128 plus 2 plus 1. Okay, so this number is minus 125. Now, first glance, you might go, what? But it's because this one, instead of being with 120, is now with negative, and you work up. So if this is a 1, we've gone down to 128, then we've added 2, 126, and then we've added 1 to 125. So at first, this seems a lot more complicated, but remember, to a computer, it doesn't work the same way ours does. It just follows systems. One system to another doesn't make too much difference to a computer. One step to another step, not too much difficult. And there are great reasons for using this. First of all, the math works, okay? And there are no 2 zeros. So, you know, this method works perfectly. So let's do an example. The problem is, how do you put a number in? Well, it's a bit more difficult, but let's do some conversions from it first. So let's pick this number, and then we'll do that. So it's simply minus 128 plus 16 plus 8. Now, so when you're working from the bottom up, it's a little bit more tricky, because minus 128 plus 16 might be more difficult for math for you. I don't know. Maybe you want to add up all the other positive numbers first, so you know that's 24, and just do minus 128 and then add 24. Or whatever method you think, but basically you just got to use your normal math skills to add those numbers together. If you really can't cope with that, I'll speak to you separately, and we'll go through how to add these up using the normal column method. But otherwise you should be able to do it. So hopefully you'll work out that if I mean, you basically, in your head, what you've got to think of is 128 minus 24. It's the other way around, okay? So, and then of course it's a negative version of that number. But anyway, so if I add 24 to minus 128, I'm going to get minus 104. And that's what this number represents here. So you have a go at A, B, C, D, and E in part 1, and then I'll speak after. So pause video now. Right, I'm only going to go through the first 2 because well, I don't want to waste too much time. So this for the first 2 is that. Okay, so that's nice and easy. You should work out it's minus 128 and 4, and so that equals to minus 124. There we go. So that first one was minus 124. Nice, easy one. And then this one, let's do a more difficult one. Let's do D. I'm going to go through D, and then you can check your D, because otherwise sometimes they're too easy. Right, 1, 0, 1, 0, 1, 0, 1. Okay, so this one is minus 228 plus 32 plus 8 plus 2. Just check that on the thing. Yes, that is what it was. So let's add those up first. Okay, so hopefully you can see that 2 and 8 are 10, and 32 makes 42. So basically it's minus 128, add 42. So if you don't know how to do that in the column method, it's up to you to work that out. But hopefully you can work out eventually that to get from that number to that number, I need to add 86. So this is 86, and you add it together. So this number represents minus 86. Okay. So what about showing the numbers in 2's complement? Well, it's just the same as before, really. You just have to use your math skills. If you need to show the number minus 99, all negative numbers start with 1, that's how you know. So we're on minus 128, and I need to get up to minus 99. So basically I need to know what is the difference between these two numbers, really. And once I find the difference out, I just stick them in. That's basically it. So you should know that with minus 128, it takes 28 to get to minus 100. And so then it's obviously 29 to get to minus 99. So I just need to make 29 as always. And hopefully you can just do 29 on here. So 29 as normal. So now I just need to do 29. So the first one is 16. Okay, because that's the biggest, highest number. And then I'm left with 13 to go. So 1, 8. I'm left with 5 to go. And then 1 and 1. And all those numbers add up to minus 99. Okay, and you can check this in the exam. It's a real shame when I see a lot of top set math students in year 11 getting questions wrong, and really it is just basic mathematics that you need to be able to answer. There's not much I can do to teach you how to do this apart from add up better. So do the first 5 questions on there, and then I'll go through 1 or 2 of them, but I'm not going to go through all of them because they're the same. So pause it now. Right, so I'll do minus 28, so that's actually quite a difficult one. It looks, numbers that are closer to 0 are actually harder because there are more numbers here. So this is C I'm doing. So obviously straight away it's on 128, minus 128. Now actually the first bit, I suppose at least you should know that I need to add 100 to get from minus 128 to from minus 128 to minus 28. So now I've got 100 left. So now it's just basic binary. Do 100 using these bits. So 1 and 1 is 96. Okay, you should be able to work that out, and then you're left with 4, and the answer is simply that. And then that, and that add up to minus 28. Okay, so that's C. Minus 5, probably the most difficult one. Okay, so minus 128. So that means the difference between that and minus 5 is 123. So you just need to do 123 here. So bang and bang makes 96. Okay, 112, and then you're left with 120, 122, 123. If you can't do that how I did it in my head, then you're going to have to do it in the very slow method of doing the math, of working out a difference between those two numbers, and then doing, right, I've done 64, do that minus that and see what you've got left, then do 32, you know, and see what you've got left slowly. Okay, so what I want you to do now is pause the video and then write out from memory what are the issues with using 2's complement, with using a sign bit instead of 2's complement with negative numbers. It's a very common exam question. So what are the problems with using a sign bit instead of a 2's complement? Do it from memory, so close the video and then write it so you get used to writing it without looking at the answers.